Okay, let's solve first question of the quiz. So let's use the first property that we learned in log, which was we have a into log b, we can write this as log b to the power of a. Right? So let's use this property here. We'll have log 2 to the base 10 plus log 10 16 by 15 to the base to the raised to power 16. So we take 16 as the power plus log 10 25 by 24 to the power of 12 plus 7 log. Let's take 7 also there, 81 by 7. And now use this second property, which we said that log of x into y is equal to log of x plus log of y, right? So log of x multiplied by y is log of x plus log of y. So let's use this property here. So log of 10, this is 2 into, this is 16, so I can write this as to the power of 4 into 16 by 3, 2 to the power 3 into 5, so 3 to the power of 16 into 5 to the power of 16 multiply by 25, so I can write as 5 square into 12 upon 24, so I can write as 2 cube, which is 8 into 12, 8 3 is 24, 3 raised to the power of 12 multiply by 81, which is 9 square, 3 raised to the power of 4 into 7 by 80. So we can write 80 also as 40 into 2, or 8 5 is 40, or 16, so we can write 40 into 2, or which is basically 5 into 8 into 2, which is 2 raised to the power of 4, and then the 7 into 5 raised to the power of 7, right? If I solve this, we get what? 16 for 64, right? So that will make 264 plus 165 multiply by this 5, 12 to the 24 multiply 3 raised to the power of 28 by 3 16 plus 12 28 5 and 5, so 16 plus 7, which is 23, to 2 raised to the power of 12 to the 36, 36 plus 28, which will make it 64. So that is log 10. So that's 1 2 out of this. This full will get cancelled into 5, which is log 10 to the base 10, which value is equals to 1. Cool. So we have used two properties of log here, which we says a log b is equals to log b to the power of a, and log of x plus y is same as log when we take both x and y as a multiplication. The first property we have used. These are two properties of logs we have used in this question. Let's do second question. Okay, let's solve this second question. So what are the properties that we have learned? We have seen. So we have seen that a log c to the base b is equals to c log a to the base b. So that is one property we have seen, and if you want to see the proof, you should go back to some old videos. And a log b to the base a is equals to b. These are the two properties that we have seen. So now let's apply this. So let this is same as 2 log 5 to the base 3. However, change this, which is minus 2 log 5 to the base 3. So apply this property. So we say it's 2, 5. So we exchange the values and we get 5 log 3 to the base 2 as same as minus 2 log 5 to the base 3. Right? Let's take this value as same and again use this particular property here. So this will then change to 3 log 7 to the base 2 plus, what is this value? Apply this property, a log b to the base a. So this property becomes 11 minus, this is 2. What we can write is this is 2 log, 2 is the power of 2 log 3 to the base 2. Right? We can write 4 as 2 squares. So what does this mean? So this and this cancel out. This and this cancel out. So I get 11 minus 2 log 2. Now we can take 3 as the power, 3 square. Again apply this particular property. So this is 11 minus 3 square, which is 11 minus 9, which is equals to 2. Alright. So these two are very important properties that you should remember overall. And if you want to see the proof, that has been done in previous videos. Cool. Let's solve third question. Okay. So let's solve question 3, where we're saying summation over n equals to 1 to 103 log of 1 plus 1% to the base 2. So let's solve this. Let's first expand this series. So we say n equals to 1. This will make log to the base 2 plus n equals to 2 will make this, n equals to 3 will make this, and so on. 1 plus 1 upon, let's substitute n as 1023. So this will be log 2 to the base 2 plus log 2 3 by 2 plus log base 2 4 by 3. This is equal to log 2 1 0 2 4 by 1 0 2 3. Now what does this mean? So this is summation of log. So we have seen a property which says log of x plus log of y is equals to log of x into y, and this can be generalized for any amount of summation. So we can generalize this value and we say this would be log 2, which is 2 into 3 by 2 into 4 by 3 into what would be the next number, 5 by 4 and so on, into 1 0 2 3 by 1 0 2 2 into 1 0 2 4 by 1 0 2 3. So what is this? Log 2. This will cancel out, 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 and this will cancel out, and this will get me 1024. What is 1024? It's 2 raised to the power of 10. Now we again use the property of log when we can take 10 as the multiplication term, log 2 to the base 2, and any base is 1, so this will come as 10. Right? So again we have used the same properties, log x plus log y, or plus and then for that matter log z as summation of log when converted to one log becomes multiplication, and the power is basically can be written as a multiplication. Cool. Let's solve question number 4. So what will we do? We need to find x here. So first we will need to get rid of logs somehow in order to solve for x. So how do we do this? So these are logs, so in summation, so we need to get it into multiplication. That's how we can get rid of logs. So let's solve this. So we can write this as log 2 log x to the base 2. This is a multiplication, so this can go as a power whole square. Right? Now let's apply a log base changing theorem here. So we can say this is log base 2 log base 2 2 root 2x, right? So and take this log down. So what we have now used is a base changing theorem. We have applied to this log quantity. Yeah. So what does this give? This gives log 2 log x to the base 2 whole square. Now log 2 to the half is equals to minus 1. This value is equals to minus 1. This will become minus log 2 root 2 x equals to 1. Now let's use another property. We say log of x minus log of y is equals to log of x by y, or so we can say this and this. So we can get rid of this log. We say this is 1 log. So this is basically the numerator. So the numerator will become this, and we get denominator as this. Right? Now let's see this value. We can write this as log x to the base whole square upon this. How I can write it? I can write this as log 2, and this is what? 2 root 2, which is 2 raised to the power of 3 by 2, right? So 2 raised to the power of 3 by 2 plus log x to the base 2, right? Multiplication is converted to summation, and I can write 1 as log 2 to the base 2. So what does this mean? This equation get equated to this equation, so I get log x whole square. What is this value? So this value becomes 3 by 2, because I can take 3 by 2 and log 2 to the base 2 is 1, plus log x by 2 equals to 2, right? So what does this mean? Log x whole square. Now you solve this equation, you will get minus 2 log x to the base 2, and this goes here, minus 3 equals to 0. If you solve this, what will you get? You will get log x to the base 2 plus 1, and this is and log x to the base 2 plus 1 minus 3 equals to 0. So log x to the base 2 equals to minus 1, or log x to the base 2 is equals to 3, right? So what will give? So this will give, so this equation will give me x equals to half, and this equation will give me x equals to 8, like 2 cube 8. Again, by definition of the log, we know that log x to the base equals to n, then x is equals to 8 raised to the power of n. So we apply this here, 2 cube 8, and similarly 2 raised to the power of minus 1. Now, so this is the two possible solution. Now let's see whether these two solutions are feasible or not. So if I take log x equals to half and substitute here, what will happen? So this equation will become, and let's use the space somewhere. So if I put x equals to half, this becomes log 2 root 2. So this becomes log of half log of 2 log of root 2, which is log of half two raised to the power of 1 by 2 is equals to 1. And if I put log of x equals to half here, this will also get solved. So if I put log x equals to half in this equation, I will get 2 log 2 half 2 log 2 of minus 1, right? Now log of negative is not defined, hence x cannot be equals to half, right? So if you put x equals to half, this log is not defined, so hence this is not feasible. So only the solution is x equals to 8. And this is something which you need to be very, very careful about, right? You may get multiple answers when you have to solve such equations where you have to find the value of quadratic. However, once you get the solution, you need to check back whether the original equation is defined or not defined. So this could be a perfect solution. However, it's render one of the value as not defined. So only solution for this equation is x equals to 8. Cool. Let's do question number 5. Question 5. So let's solve some of these remaining questions of the quiz in the next video.